Okay, so today we will start our next journey towards solid state. See, first of all, we have completed the theory, then exercise questions, then NEET questions, okay, from last 5 years. Now we will start to solve the IIT JEE main and advanced questions. We will start from 2021. So there are two questions from 2021. Okay. Am I audible to you? Hello. Okay. So let us start. First question from JEE Main 2021. It is came in on 24th Feb morning shift. It is a numerical type question. The coordination number of an atom in a body centered cubic structure is. Assume the lattice is made up of atoms. Tell me. So what is the coordination of an atom in a body centered unit cell? Yes, beta. Body centered unit cell, body centered cubic structure. So what is the coordination number? You know, in BCC, atoms are at the corners and body center. Atoms are at the corners and at the body center, right? Now, atom at the body center is in touch with all the corner atoms, is in touch with all the corner atoms, and all corner atoms are in touch with how many unit cells? 8 means body center of each unit cell is in touch with it. That means what is coordination number of an atom in a body centered cubic? Fast, very easy. I have explained already. Yes, beta. What is the coordination number of an atom in a BCC lattice? Fast. Obviously, it is 8. In a body centered, it is a fact based question. Very good, Abhay. It is 8. Okay. Is just put the numerical value, that is 8. Okay. So let's go to the next question. Question came in on 25th Feb in the evening shift. Keep in mind, in JEE main question, there are sometimes there is question from solid state, and it is not necessary that there should be a one question always. Okay, keep in mind. Now, this question came on 25th Feb, the evening shift. Unit cell of copper corresponds to a face centered cube of edge length is given to you. Edge length is given to you, that is 3.596 angstrom. But say calculated density of calculate density of copper in kilogram per meter cube. That means A should be in meter, that is 10 raised to power minus 10 meter. Okay, then with one copper atom at each lattice point. Okay, and FCC, if it is FCC, then Z is 4, and density, so what is density? Z into M divided by A cube into Na, right? And molar mass is given to you, that is 63.54, but it should be required in kilograms. Okay, just put the value 4, that is 4, and M is 63.54 into 10 raised power minus 3 kilogram divided by A is 3.596 into 10 raised power minus 10 meter cube, and Avogadro's number 6.022 into 10 raised to power 23, right? That is in kilogram per meter cube. It is 463.54 divided by 3.596 raised to power 3 into 10 raised to power minus 30, 6.022 into 10 raised to power 20, 10 raised to power minus 3. That means it is 3.596, take it as 3.6. Okay, because we have to approximate the density, right? So it is 4 into 63.54 divided by 3.6 cube into, it has 6 into 10 raised to power minus 3 and plus 30 and minus 23. Yes, beta. So value comes out to be 2, 3, 3, 2, 1, 1, 8, 1.18. So it comes, it is 42.36 divided by 3.6 cube. What do you what is 3.6 cube? Solve it. Into 10 raised to power 4. Yes, 3.6 cube. It is see, because you don't have to use the calculator. Okay, that is the main crux. Follow beta. Is 42.36 divided by 3.6 cube. So 36 into 36 is 69196 then 1296 further multiplied by 36. Am I right? Value comes out to be 46.65, or we can say 46.66. That means it is very close to 1. Okay, so value, see, it is 42, it is 46, so you can take it as 0.9, around about 0.9 46.7 and 42.4. It is 0.9 24.9. One 0.2 around 0.902 around into 10 raised to power 4. You can write it as 9020 kilogram per meter cube, or it is, you should go as close as possible. Okay, I have approximated so much. Options are not there, keep in mind, this is numerical type, so you should write the numerical value. Okay, there is a range in JEE main nowadays, there is a range. Okay, put it away. So exact value that is calculated is 0.9076, so it is 9076, but there is a range of value. Actually it should be like 900 to 980 and so on, like that. Okay, so any value close to it is taken as correct. Next question came in 26th Feb, evening shift. Number of octahedral voids per lattice site in a lattice is, number of octahedral voids per lattice site in a lattice is, rounded off to the nearest integer. See, it is not written as number of octahedral voids per sphere, है ना, per unit. ठीक है ना, number of octahedral voids equal to number of spheres involved in close packing, right? But here question is number of octahedral voids per lattice site, per lattice site. Okay, so you know, for FCC, let us consider the case of FCC. For FCC, how many lattice sites are there? Number of lattice sides are 8 corners. Lattice sides 8 corners and 6 faces. Total lattice sides are 14, right? Total lattice sides are 14, and number of octahedral voids. What are the locations of octahedral voids? So edges, edge center, 12 edge center plus 1 at body center, means total octahedral voids locations are 13. So number of octahedral voids and number of lattice sides. That is 13 by 14. That is 0. More than 9, 0.92857 means round about it is 1. So you can directly write 1 because it is rounded off to the nearest integer. So it can never be 2. Okay, it is always very close to 1. Done. These are the questions from IIT JEE 2021. Now IIT JEE Main 2020. Okay, numerical type question. In a solid substance, edge length of the unit cell is given to you. Edge length is 405 picometer. Edge length is 405 picometer. Okay, and density of the solid is given, is 109 10.9 gram per centimeter cube. Molar mass is also given to you, 109 gram. To find the radius of the atom which form this unit cell in picometer. You have to calculate radius of the atom which form this unit cell in picometer. That means first of all we have to calculate which type of unit cell is this. You know, formula is D equal to Z to M by A cube into Na. Means Z will decide the type of unit cell. Z is equal to A into A cube into Na. Okay, but it is in picometer. So if it is in picometers, it is multiplied by 10 raised to power 30. That is equal to D into A cube into Na divided by M into 10 raised to power 30. So D is 10.9 and A is 0.5. If A is in picometer and D is in gram per centimeter cube, then we have to multiply it by 10 raised to power 30. That you know. 405 cube, Avogadro's number 6.022 to 10 raised to power 23 divided by M. M is 109 to 10 raised to power 30. Okay. Z 10.9, 109 is 10, 405. So take it as 4.05 cube, okay, into 0.022 into 10 raised to power 23, and here it is 6, 10 raised to power 29 divided by 10 raised to power 1. Am I right? 23 and 6, 10.9 and 109. Done. Is 10 raised to power minus 2. 2, 4 4 ja 16, 4 ja 64. Take it as 64, take it as 6. 4 ja 24. 384 into 10 raised to minus is 3.84. That means 4. Means it is FCC lattice. Unit cell is FCC. As unit cell is FCC, so what is the relation between R and A? R is equal to A by 2 root 2. A is 405 divided by 2 into root 2. That means it is 2.5 divided by 1.414. Take it as 1.4. Yes, value comes out to be, yes beta, 202.5 over 1.4. So yes, okay, so can take it as 14, take it as 2025. Okay, 14 ones are 14, comes out to be 625. 14 was a 56, so it is 55, right? Again 14 fives are, okay, oh no, 14 fours are again 56, comes out to be 9. And round about 144.6 picometer. Okay, you can take it as round about 144 picometer, but less than that. Okay, because 1.414 is taken as 1.4. Okay, that's why value is less than 144. Okay, you can write it as 143.8 picometer or like that. Okay, because there is a range of numbers. Okay, so if you intelligently guess it, then answer is close to it and you will get full marks. Okay, okay, good evening. Yes, minimum distance between the center of two octahedral voids in FCC lattice in terms of edge length. Yes, beta. Minimum distance between the center of two octahedral voids in FCC lattice in terms of edge length. Abhay, very good. It is approximately 143, but more than 143, right? Yes, beta, bolo. Minimum distance between the center of two octahedral voids. You know what is the location of octahedral voids? Location of octahedral voids. Location of octahedral void is edge centers and body center. So minimum distance we have to calculate, right? So you know edge center, this edge, center of these edges, and this is the shortest distance. So say this part, because it's center of the edge, is a by 2, is also a by 2. So what is this? Take it as x, distance between the two octahedral voids, minimum distance. So apply Pythagoras. So x square equal to a by 2 square plus a by square. That implies a by 4 plus a square by 4. That means a square divided by yes, a, one second. So yes, beta. So it is a square by 2, x comes out to be square root of a square by 2, guys, is a by root 2. That means the right option. Okay, तो थोड़े से देखो डिफरेंस देख लो, नीट और जेई के क्वेश्चंस में डिफरेंस. नीट के क्वेश्चन डायरेक्ट थे, है ना, डिफरेंस मतलब डिफिकल्ट नहीं था कैस करना, बट यहाँ पे क्वेश्चन टू ए स्क्वेयर the question is minimum distance in the center of two octahedral voids in FCC. You know, in FCC, octahedral voids are at the edge centers. This is edge center, this is also edge center. Edge center means it is at the half of the edge, so it is a by 2, this is also a by 2, and there is a 90-degree angle. Okay, so distance between these two octahedral voids is, it is like this. This is a by 2 and this is also a by 2. One octahedral void is here, other is at this point. Distance is this one. This distance is hypotenuse of this right angle triangle. Okay, that's why we get it like this, applying Pythagoras. Okay, Ika, got it? Okay, next question came in 6 September 2020. In a metal oxide, oxide ions crystallizes in a CCP lattice. न्यूमरेटर में 2a स्क्वायर, ओके हाँ सही है, 2a स्क्वायर ओवर 4 हो जाएगा ना, हाँ तो a स्क्वायर बाई 2 ही हुआ ना, सही है. ओके ग्रेट ग्रेट राइट. ओके नाउ question is, in a metal oxide, oxide ions crystallizes in CCP lattice, in which metal M1 occupies 50% of octahedral voids and metal M2 occupies 12.5% of tetrahedral voids. Then oxidation states of metal M1 and M2 respectively are. You have to calculate oxidation states. Okay, now you know in CCP lattice Z is 4, so number of octahedral voids, that is equal to same as the number of atom per unit cell, and number of tetrahedral voids is equal to 8, double of that number. Okay, now M1 occupies 50% of octahedral voids. That means how many M1 atoms are there? Number of M1 atoms, that is 50% of octahedral voids, that is 50% of 4, that means that is equal to 2. Okay, and what about M2 atoms? M2 occupies 12.5% of tetrahedral voids. That means number of M2 atoms, that is equal to 12.5% of 8. 12.5 into 8 is 100. Okay, that means is 1, comes out to be 1, because 12.5 into 8 is 100. So it means formula of the compound is M1. How many M1 are there? 2. How many M2 are there? 1. And oxide ions form the CCP. That means number of oxide ions, that is 4. So O4. Okay. So what is oxidation number of M1 and M2? You know, total charge on oxide ions. The charge on oxide ion is equal to 8. 8 negative. Magnitude of the charge ले रहा हूँ. Total magnitude of charge, okay, that is 8. So charge on M1 and M2, total charge on M1 and M2 should be 8. 2 into charge on M1 plus 1 into charge on M2, that should be 8. So if you have plus 2 and plus 4, that means 2 into 2 plus 4 is 8. 2 into 1 plus 3, that is different, plus 3 and plus 2 is 2 into 3 plus 1 into 2 is also equal to 8. Okay, that means the answer can be plus 2 and plus 4 or plus 3 and plus 2, but you know it is AB2O4 type structure. AB2O4, okay, and this is spinel type structure. So in spinel type structure there are plus 2 and plus 3 oxidation states. Okay, there is no need to go through all this, just you can identify if you know the spinal structures. I will share the video of spinal and inverse spinal structure. You know about this spinal and inverse spinal structure? Yes beta, have you gone through that spinal and inverse spinal structure? Yes, tell me, do you know about spinal and inverse spinal structure? Yes Abe, Nika. Spinal and inverse spinal structure, have you done that part? Okay, I will share today. I will share the video today. Okay, about spinal and inverse spinal structure. Okay, so that is AB2O4 is a, it is just like MgAl2O4. Okay, that is spinal type structure. Okay, now questions from IIT JEE Main 2019. Question is, at 100 degrees Celsius, copper has FCC unit cell with edge length x angstrom, edge length x angstrom. So what is the approximate density of copper at this temperature? Tell me. So you know density, just write the formula of the density, Z capital M over A cube into Na. Okay, density is in gram per centimeter cube. So for FCC, Z is 4. What is molar mass? The approximate, okay, copper. So for copper, what is molar mass? 3.5 that you should know, or it is given to you. Okay, AQ. So A is X angstrom. So should be in centimeter. Angstrom in centimeter, 10 X into 10 raised power minus 8 cube to Avogadro's number 6 into 10 raised to power 20. Take it as 6, okay, rather than 6.022. Now it is 4 into 63.5 divided by x cube into 6 to 10 raised to power, it is a 24 minus 4 and plus 23. So it is 423.5 over 3 x cube into 10 is 635 over 3 into x cube. That means 3 to the 2 there na 2 into 2 into 2 1 1.6 for x cube. That means it is 2 to 6, 3 ones are 3, 1s are 3, 20, the 6, 19, okay, is 422.6 423.2 divided by x cube. That means it's very close to 422 x cube. Okay, so option 4 is correct. Okay, I think this is easiest one, you can do it. Question came in 9th Jan, evening shift. Okay, 10th question you have to do by your own. Yes, beta. Now it's your turn. I think it is very easy question, you can do it. I will write the next question. This question is for you. Compound of formula. I am writing next question. That question came in 10th Jan, morning shift. Compound of formula A2B3. Okay, Anika. Abhay is right or wrong? HCP, yes, very good. So it is triclinic because it is written which primitive unit cell has unequal edge lengths and all axial angles different. So for triclinic, A is not equal to B, not equal to C, alpha is not equal to beta, is not equal to gamma, is not equal to 90 degree. It is most unsymmetrical system. Option 1 is correct. Now next question. Compound of molecular formula formula A2B3 has the HCP lattice. So which atom forms the HCP lattice and what fraction of tetrahedral voids occupied by the other atoms? Options are HCP lattice by A and 2/3 of tetrahedral voids by B. Second option is HCP lattice by A and 1/3 of tetrahedral void by B. Third option is HCP by B and 2/3 of tetrahedral voids by A. And fourth option is HCP by B and 1/3 of tetrahedral voids by A. Yes. So which option is right? It's also for you. Formula is A2B3. You have to identify which atom forms HCP and what fraction of tetrahedral void is occupied by the other atoms. Next question. I will write the next question. You will do it. Same 10th Jan, second shift. We noted down the question. Compound of formula A2B3 has HCP lattice. Which atom form HCP lattice and what fraction of tetrahedral void is occupied by the other atom? So which option is correct? Next question is solid. You will solve the question. Density of 9 into 10 raised to power 3 kilogram per meter cube forms FCC crystals of edge length 200 into under root 2 picometer. What is the molar mass of the solid? Avogadro's constant is 6 into 10 raised to power 23 per mole. Value of pi is around about 3. Take value of pi as 3. Yes, beta. What is the answer of previous question? 0.0432 kilogram per mole or 0.0216 kilogram per mole or 0.0305 kilogram per mole or 0.432 kilogram per mole. Yes. Option A. Anika, go with option A. Okay. What about, okay, if I take this option, then HCP, that means number of A, let us take it as X. So tetrahedral voids, that become 2x. Okay. So number of B, that is 2/3 of 2x, means it becomes 4 by 3x. So A is to B becomes x is to 4 by 3x, means 3 is to 4. So formula become A3B4, but it is A2B3. So for first option, that means first option is not correct. If I choose next option, second option, then number of A forming HCP, take it as x, number of tetrahedral voids again 2x, and number of B becomes 1/3 of 2x, is 2 by 3x. So A, okay, that was for previous question. Okay, sorry, I thought of this question. Do this question, beta. So is x is to 2 by 3x, that means 3 is to 2. Formula is A3B2. It is A2B3. So obviously fourth option is correct. Why? Because number of B becomes, number of B, take it as x, number of A 1/3 of tetrahedral voids. So 2 by 3x, that is A is to B is 2 by 3x is to x, that is 2 is to 3. Formula become A2. Got it? That means fourth option is correct. Okay. Yes. What about this question? This question from 10th Jan, evening shift. Yes. Question from, you will solve this question, I will write next question. Morning shift. Number 12. The radius of the largest sphere which fits properly at the center of the edge of a body centered cubic unit cell is, edge length is represented by A. Options are 0.027A, 0.047A, 0.134A, 0.067A. Yes, beta. Tell me about this question. Yes, solid having density 9 into 10 raised to power 3. Okay, and you know density is equal to Z into capital M divided by A cube into Na. Calculate molar mass. M is equal to A into A cube into Na and divided by Z. It is FCC, so Z is 4. Option C. Good. Density is given 9 into 10 raised to power 3, right? And A is given 200 into under root 2 into 10 raised to power minus 12 in meter, and Avogadro's number 6 into 10 raised to power 23 divided by 4. So is 9 to 8 into 2 root 2 into 10 raised to power 2 and 10 is 10 minus 30 into 6 into 10 raised to power 3 to 10 raised to power minus 30 into 10 raised to power 23 and divided by 4. 4 to the 8. Is total from 10 raised to power minus 4 to this is 6 6 the 1 6 216 into under root 2. So 2 means 1.4. So 14 6 ja 84 into 2 3024. 3024. It is not taken as 1.414. 1.414. I have taken only 1.4. Okay, so 1.4 it is 302.5. 302.4. So if we take whole thing, so it is around about 305. Okay, means value is means approximate value comes out to be 302.4. It is 0.03024 kilogram per mole. Option C is correct. Okay, last question of the day. Okay, we will take other questions the next round. So question is the radius of the largest sphere which fits properly at the center of the edge of a body centered cubic unit cell is. Center of the edge. Tell me. You know, for BCC, to know the radius of the sphere, radius of the atom equal to under root 3a by 4. You can take it as small r. Is the radius of the sphere is under root 3a by 4 in actual. So we have to calculate the radius of the largest sphere which fits properly at the center of the edge. Okay, so you know empty space at edge center is equal to A minus 2R. That is A minus under root 3A by 2 is diameter of sphere. Okay, so radius of the sphere at the center, it is equal to A minus under root 3 by 2A divided by 2, half of the diameter. It is A 2 minus under root 3 divided by 4. So it is 2 minus 1.732 divided by 4A means D. Very good, beta. You are right. 8, 6, 2, 0. 0.268 by 4 means 0.06 to the 24, 48. So 28, 7 for the 20. Okay, 0.07A, because you know for BCC body diagonal. Okay, this is one sphere, this other sphere. So it is radius of the sphere which fit in between them is okay. Radius of the largest sphere which fits properly at the center of the edge. Okay, sorry, it is center of the edge. So one sphere is here, other sphere is here. So that because spheres are not touching along the edges, spheres are touching along the body diagonal, that you know. Okay, so in between the edge there is a gap. In that gap, what is the radius of the largest sphere which can fit? We can calculate. If this radius is small r, this radius is also small r, then edge length is A, total length is A minus 2r, that is diameter of the sphere, and if it is divided by 2, then that is the radius of the sphere which can fit in that particular place, A minus 2r, and r for BCC that we have under 3A by 4. Okay, that's all for the day. Thank you so much, beta. God bless you all. Bye bye. So go through all these questions once again.